From here on Earth, our sun looks steady and unchanging. But close up, it's a dynamic, active place. And sometimes you'd see bursts of radiation called solar flares and explosions of plasma and magnetic fields called coronal mass ejections. But when the coronal mass ejections hit Earth, our magnetic field can go haywire. Powerful electromagnetic currents generated during these storms can harm our power grids, global positioning systems, communications networks, and spacecraft and astronauts on orbit. Meet SWFO-L1, NOAA's first purpose-built space weather observatory. From its unique vantage point at Lagrange Point 1, 1.5 million kilometers from Earth, SWFO-L1 keeps an eye on the sun's corona 24/7 without interruption to provide early warning of solar storms heading our way. The spacecraft's crown jewel is its compact coronagraph, its eye on the sun. Just like the GOES-19 coronagraph, it allows SWFO-L1 to detect even the fastest coronal mass ejections right as they happen. The spacecraft is also packed with a suite of new instruments that allow it to make real-time measurements of the solar wind's velocity, density, and temperature, and variations in the interplanetary magnetic field, all to provide better forecasts of incoming space weather than ever before. All of that technology floating out in space on SWFO-L1 works together closely to keep us safe back here on Earth. Here's how it works. When a solar storm erupts from the sun, SWFO-L1's coronagraph observes the event right away and sends the data back to the SWFO ground segment, a network of antenna stations all over the world, with the SWFO command and control in Maryland. But spotting a storm is one thing. Actually measuring it close up is another. It's the difference between tracking a growing hurricane on radar and flying through the storm on a Hurricane Hunter aircraft. SWFO-L1 does both. After the spacecraft spots a storm with its coronagraph, it watches the approaching weather and waits. Somewhere between 18 and 70 hours later, the incoming storm passes over SWFO-L1. Then, the spacecraft's instrument suite measures the storm's severity and speed and sends that data home too, giving NOAA early warning somewhere between 15 and 60 minutes before the storm arrives at Earth. NOAA's Space Weather Prediction Center in Colorado is constantly on the alert, using all the data SWFO-L1 collects to develop and communicate real-time forecasts and warnings to industry, government agencies, and the public, so they can take action before the storm arrives to minimize its impact. Those actions might include putting satellites into safe mode, rerouting polar airline flights, sheltering in a safe area on the International Space Station, or changing loads on the power grid. In our increasingly technology-dependent world, we're more vulnerable than ever to solar storms. But at the same time, our fleet of space weather satellites is aging out of service after many years of work in the harsh environment of outer space. That's why SWFO-L1 is the first of a new generation of sun-observing spacecraft that NOAA is launching. SWFO-L1 will use its cutting-edge observing technology to provide NOAA forecasters the best and most reliable data available and ensure our nation doesn't go a minute without eyes on the sun, our life-giving but turbulent neighborhood star.